So next let us prove that this EH, that is a subfield of the field extension field E. For that, if we take two elements, let x and y belonging to E of H, then we would prove that the element E minus y also belongs to E of H, and the element x inverse also belongs to E of H. If these two properties are proved, to prove these two things, if these are proved, then your EH, that becomes a subfield. And we'll also prove that xy belongs to EH. So for proving that, we take for all sigma belonging to H, sigma of x minus y. What is this thing? Because this mapping sigma, that is an automorphism. That means it would be 1, 1, it would be onto, and it would also be homomorphism. And what does homomorphism do? It preserves the structure. So that means you would have sigma of x minus sigma of y. So that means we can separate out all the terms. And what is sigma of x? Because this is 1, 1. This is an identity mapping, right? So it would be equal to x and it would be equal to y. So from here we got that sigma of x minus y, that is equal to x minus y. Therefore, x minus y belongs to E of H. Why? Because these elements were present in E of H. That means sigma of x was equal to x and sigma of y is equal to y by definition of this EH. And now because sigma of x minus y is equal to x minus y, so that means this x minus y also belongs to E of H. So from here, this element is present in E of H. Next, we'll also say that what is the additive identity? The additive identity is 0, which is the same as that of the given field, and the multiplicative identity, that is equal to 1. Moreover, if we have x belonging to E of H, this implies that for all sigma belonging to H, sigma of x would be equal to x. So that means consider sigma of x inverse. So because this is a homomorphism, so we can write sigma of x raised to power minus 1. This is by the property of homomorphism. And what is sigma of x? Sigma of x is x because it belongs to E of H. So sigma x raised to power minus 1. So from here we can say that sigma of x raised to power minus 1, that is equal to x to the power minus 1. And hence this x to the power minus 1 also belongs to the set E of H. And similarly, if we take any two elements x and y belonging to E of H, and then for all sigma belonging to E of H, the element sigma of x is equal to x and sigma of y is equal to y. So that means sigma of xy is equal to sigma of x multiplied by sigma of y, again by using the homomorphism property. And what is this? This is x and this is y. So we have sigma of xy is equal to x of y. So that means this xy belongs to E of H. So from here we can conclude that this is a indeed subgroup, and moreover this is a subfield of E. So we remark that this element, in fact this EH, that is which was the fixed field, this act as an intermediate field between E and F. So that means you have F here, you have the extension field here. So in between we have E of H.
here.